Joining us now, aviation specialist Glenn Farley. Glenn, so they're relying on 3 of these large cargo freighters. What happens if one of them has a problem? Is that a bit risky for the production schedule?
Probably not. The bottom line is that these airplanes will have to go down for maintenance, so they're going to build that into their production plans. There is a worst-case scenario backup plan, which is to basically put these parts on ships. All of the plants involved here, including Everett, have an active seaport that they can get to quite easily.
Let's talk about the composites. I know they're lighter and they're supposed to be more fuel efficient, which is great for the bottom line of the airlines. But what about passengers? I mean, is there any difference to a passenger traveling on this airplane that it's made of composites at all? What's the sales pitch on that?
Well, the sales pitch for the passengers is it will be a more comfortable plane to fly on. For example, when you pressurize an airplane, you're not pressurizing at the sea level. You're pressurizing it for several thousand feet. You will actually be at a closer to sea level pressure with this, about 2,000 feet lower.
Now, we heard that they did this bird test to testing the composites, and that one of the tail sections failed, that they have to beef up the composites in that section. I guess it just raises the question of, are there a lot of unknowns still about these composites in a commercial aircraft?
I don't really think so. I mean, the fact is composites have flown on military planes for a long time. Airbus has used composites for a long time. Boeing has used composites for a long time. People aren't aware of this usually, but the tail section of the 777 that's now been flying since 1995 is built out of composites, like this airplane will be, and they did that largely to test to see just what composites would do in service.
Okay. Well, let's continue with Glenn's report. You went to Japan and Italy, where a lot of large parts are being made. Let's see what you found.
This is southern Italy, the poorer part of Italy. Yet this is where one of Italy's largest corporations has put one of the world's most advanced factories for composites.
Giovanni Bertolone is CEO of Alenia Aeronautica. Alenia will make some of the biggest body pieces for the new 787, all in this brand new factory in Grottaglie, Italy.
We had 25 years of experience in carbon fiber.
This huge factory, about as large as a bay at Boeing's Everett plant that will assemble the jet, is just for 2 big body parts.
Just to produce 787 for section 44 and 46.
The reason that we went to the companies that we have selected is because of the value they bring to the airplane.
Scott Strode is Boeing's vice president for 787 development and production.
And I think we're evolving as the global marketplace evolves.
But it's not just Italy. There's an even bigger player. Japan is a very busy place, a very wealthy country, which is one reason why it is such a huge aviation market. And one reason why Boeing came here a long time ago to do business. You've heard of Subaru cars. Maybe you own one. But Subaru is just part of a bigger company called Fuji Heavy Industries. Fuji's been working with Boeing for decades, and these are not 787 parts, but a gigantic wing box for the Boeing 777.
There are 1,000 rivets to join the stringer and panel together for just one sub-assembly.
The contrast between current aluminum construction techniques and the future of composite plastics is dramatic. This is the same parts you just saw, but for the new airplane. There are no rivets here. In composites, multiple parts are fused together in those giant autoclave ovens to form one part. And Scott Strode is impressed.
They've done a really good job in getting to this point, so no surprises.
The fabric of the new airplane goes beyond the carbon fiber material it's made from. Boeing's partners are also taking big risks. They've invested millions in new factories, new tools, and their fortunes will rise and fall in part with sales of the Boeing Dreamliner.
Back with King 5's Glenn Farley. Glenn, what is driving Boeing to build these parts in other countries? Is it just a matter of cost?
It doesn't seem to be a matter of cost at all. In fact, Mark Blanda with the Machinists Union, who has also been to Japan and talked to union officials over there, argues that it's actually more expensive for them to build these parts there than it would be to build them here.
Well, that's interesting. So what is driving Boeing?
Well, Boeing really wants to, it says this. that these companies they're working with know a lot about this technology and bring something to the table. They say, look, we're a global corporation. We send these planes out all over the world. They want to pull information back in from all over the world. And they say, you might as well be a partner with them.
So they're getting information from other countries. What about the other way around? But John Newhouse in his book says Boeing is farming out key technologies such as the wing to Japan. Does that open up the door for a possible threat of a competitor emerging from Asia?
Well, it's been a big concern. I would say the concern about a so-called Asian Airbus was a much bigger deal back in the 80s and 90s than it is now. And I think the wing is probably an indicator of that, although when we were in the Mitsubishi plant, they were being very protective about what we could film as part of that wing demonstration that they had. But the bottom line really seems to be this. Right now you have two very large competitors between Boeing and Airbus. The margins aren't great. The cost of getting into the business is huge. Can anybody make any money if there's a third competitor? And that remains doubtful.
Glenn, thank you. In the past, a new Boeing jet would mean thousands of new jobs. Let's go back to Glenn's report as he explains why it's much different this time around.
This is a giant mandrel, a tool that shapes big parts for the 787. Mitsubishi, like Boeing's other partners on the Dreamliner, is shaping a changing airplane business. In this factory, workers are building something Boeing had previously built in-house, airplane wings. It's another sign of big changes brought on by the Dreamliner. Just over 3 years ago, Boeing made one thing official.
That the 787 will be built right here in Puget Sound.
But there would be no illusions. Boeing made it quite clear then that the number of assembly jobs in Everett would not be in the thousands. It would be closer to 1,000. After all, the new airplane only has about half the number of parts. And a few weeks ago, Boeing said the number of workers, mechanics, assemblers, so-called touch labor, would be closer to 800. But for the machinists union, there was hope there would be more jobs, especially after the union used its political muscle, along with former Governor Gary Locke, to get a $3.2 billion tax break package for the aerospace industry.
To go outside and give away such large packages of work might help the bottom line, but it hurts this community.
But if we learned one thing during our worldwide tour with Boeing this year, it's that there are not a lot of jobs associated with the 787 in any given plant. Contrast the number of workers at Fuji Heavy Industries in Japan that rivet together the wing box of the 777 to a relative handful in this clean room doing essentially the same thing.
30 people more required to build metal assembly.
At the Vought plant near Charleston, South Carolina, employment will top out at 375 jobs. The layup of all that black composite tape is done by computers.
It doesn't take a lot of people climbing all over. You take an operator and one or two helpers, and that's basically it.
Automation, simplification, globalization.
The failure, if there is one, won't be because of the union members here in Puget Sound. It'll be because the suppliers let them down. And we've always said, trust the people that have a vested interest in this airplane, and the Boeing families here.
When we come back, we'll ask Glenn about the big picture in our region. Still ahead, we have a glimpse of the future, and there aren't that many jobs. Will Boeing get much smaller in the years ahead?